Hello everyone, a warm welcome to our case study, Resource Efficient Wastewater Treatment, System Analysis of the Wastewater Treatment Plant Bramsche. Please spend me 20 minutes from your time and I promise you to present a wastewater treatment plant that has become significantly more energy efficiency despite the increase in capacity. How could we achieve this? Therefore, we refurbish the aeration basin from a surface aeration system to a fine bubble aeration system. Before I start with my presentation, please let me introduce myself. My name is Markus Leidinger and I'm responsible for the application management at the AERZEN Maschinenfabrik. Then let us start with some general information about the AERZEN Maschinenfabrik. AERZEN was founded in 1864 and therefore it is the oldest company worldwide producing compressors. In our headquarters in Germany work around 1,100 employees. We are represented by 52 subsidiaries worldwide. Approximately 1,000 more people work in our subsidiaries. Our share capital is 135 million euros. We have two managing directors. Klaus-Peter Glöckner is our CEO and Björn Irtl is responsible for the technical part. How is AERZEN set up in the headquarters and which machines do we produce for the wastewater technology? In our headquarters, the development and the construction department, the digitalization office and the worldwide sales department with the complete service are at home under one roof. You will find one of the most modern production centers with a capacity of more than 25,000 units per year. First and foremost, we produce three different types of machines for wastewater treatment plants: blower, hybrid and turbos, and we name this Performance 3 concept. We have 100% quality control for each unit and fulfill all standards and norms of a modern assembly line. Here you can see our 52 subsidiaries that are responsible for the sales in the region. Each daughter has its own sales department with an integrated service center, commissioning service and spare parts warehouse. A simple big advantage is we speak also the customer's language. We can refer of more than 100,000 references worldwide. Classic topics we are confronted with is reliability, energy efficiency, CO2 reduction, optimization of the aeration basin, heat recovery, container solution, digitalization, service contracts, rental business, and so on. Now I'd like to invite you for a short stroll over the wastewater treatment plant Bramsche. Please follow me in the north of Germany now. At first, I'd like to give you an overview about the wastewater treatment plant Bramsche. The plant was built in 1962. The capacity of the facility is 50,000 population equivalent. 50% is municipal wastewater and the other 50% comes from the industrial sector. In 2018, the management decided to convert the surface aeration system to a fine bubble aeration system. Why did they do this? The entire biology was overloaded because of a 20% increase in industrial wastewater. At the same time, the effluent values drifted up from the permitted values. Parallel to this project, there was a funding program for better energy efficiency and CO2 reduction. Now let us go into the past together. At first, I'd like to give you some information about the former mode of operation. We have a basin depth of 5 meters and two aeration basins with a volume of 4,300 cubic meters per basin. The system runs in intermittent operation with 9 surface aerators per tank. All rotors run simultaneously for 20 hours, 7 days long. The pictures show you the treatment process. The aeration basin is a combination basin. The outer ring is the actual aeration tank with the 9 mammoth rotors and the inner ring is the secondary sedimentation basin. The smaller picture shows you a mammoth rotor in magnification. Where were the biggest challenges in this project? The surface aeration system was more than 30 years old. Therefore, there were problems in terms of different things. The plant had high energy costs. The oxygenation was really bad. In the deeper zone, the oxygen content was very poor, and therefore the effluent values were very close to the permitted values. If the values above the limit values longer time, it means sensitive penalties of over 100,000 euros. Next problem, it was difficult to order spare parts. And we have no redundancy if one rotor is defective, and therefore the oxygen input is also lower. But the biggest problem was the increase of pollution load of industrial water. All these problems together required a conversion to a fine bubble aeration system. Now I would like to go to the present together with you. Here you can see the new mode of operation. We installed two different machines for each basin. A rotary piston compressor C52S and a turbo 8100 delivered the required airflow directly in the aeration tank via a collecting pipe system. AERSmart, an AERZEN energy management system, allows the machines to run in energy optimum during the complete running time. Inside of the aeration tank, we have placed highly efficient membrane aeration panels. Now we are going to the new compressor room. We open the door and then you can see exactly this picture here. The first machine is our delta hybrid machine. This machine is responsible for the low load operation and supporting the high load operation. Machine number 2, this is our turbo blower. This machine delivers the air for the basic load and the high load operation. Number 3 is our AERSmart, an energy management controller. In this way the machines always run in their energy optimum. What do we mean with system integration? AERZEN understands the complete treatment process in the aeration basin. Let me explain that in details. In this picture here, you can see the current treatment process from Bramsche. Inside of the tanks, we prefer to install a high-efficient membrane plates aeration system. An oxygen sensor transmits this required oxygen to the master control unit. The MCU corresponds with our energy management system AERSmart. AERSmart checks then which machine or machine combination can achieve the best energy performance status for the required volume flow, and then these machines run. All machines are equipped with a frequency converter, and it is also possible to connect foreign machines. How does AERSmart work specifically? Therefore, let's look to this diagram. On the left y-axis is plotted the specific power performance. On the x-axis, you can see the volume flow in cubic meters per minute. Inside of the diagram, you can see 3 different performance curves. The green curve is our delta hybrid machine. The black one is the turbo curve, and the red curve is the combination operation between turbo and hybrid. The deeper the curve, the better is the energy performance. Now please imagine the aeration system has a low oxygen demand. AERSmart checks all installed machines and then our delta hybrid starts, because this machine has the best performance data in this area. Exactly at the right moment, AERSmart switches to the turbo machines. In this area, the turbo can deliver the best performance data. And at this point, AERSmart decided to go into combined operation with turbo and AERSmart. So we can make sure we have the best performance data via the complete flow range. In this way, energy efficiency can be increased once again by 50%. What is the result of the new installation? Therefore, we look to the power requirement in 2017. We need 1.7 billion kilowatt hours per year. You can remember we have a 20% increasing of the pollution load up to 2021. But in this year, we only need a consumption of 720,000 kilowatt hours per year with the new installed fine bubble aeration system. And that means we have cost saving of 57%, and these are approximately 200,000 euro per year. At the end of my presentation, ladies and gentlemen, I'd like to show you the 3 most important customer benefits. The total investment of this project was around 1 million euros. The plant received 50% funding, that means 500,000 euros. In 10 years, we can save around 2 million euros in energy, and in addition, we can save more than 5,000 tons CO2 in 10 years. This, ladies and gentlemen, is the AERZEN contribution for a worth living world. Therefore, I'm thinking, let's go together to the right side of life. Thank you very much for your attention.
Thank you, Markus, for the impressive practice example. In the presentation of my colleague Markus Leidinger, you learn how machine upgrades and intelligent machine control can significantly reduce energy consumption. My name is Arndt Ohme, I'm Business Development Manager at AERZEN Digital Systems, and I would now like to show you how digital services can provide you with detailed transparency about your energy consumption and how you can also exploit further energy saving potential with less effort. Let me start with a few answers that I hear often from customers when we talk about energy consumption. One of them told me, I don't know the exact energy consumption of the individual machines. I get the electricity bill at the end of the year, and because I don't have a detailed energy consumption record, I can't check it in detail. Another request is, we would like to get ISO 50001 certified or apply for founding, but the data reporting effort is too high. Another request is, I want more transparency about the individual energy consumption of the machine, and that simply and smart without always having to look at the machine on site. Another request is, we want to reduce wasting energy and want to find hidden and excessive consumption in order to fix them and thus prevent unnecessary energy waste. Do you recognize yourself? Now I would like to show you how AERZEN can support you with these topics. With the digital service AirProgress Energy Management, you get a clear overview of current and historical energy data of all AERZEN blower. AirProgress analyzes the energy data and gives you recommendation for action to eliminate unnecessary energy consumption. Let me show you how does it work and how easy it is. In the graphic you can see the application infrastructure of AirProgress. With AirProgress we measure all important machine data such as suction pressure, end pressure, oil pressure, system pressure, ambient temperature, oil temperature, end temperature, and the operating hours of the machine. We get these data from the machine control system Airtronic. In addition, we measure all electrical values with an energy meter to get the exact energy consumption. These detailed machine data are aggregated in the AERZEN IoT gateway and sent to the AERZEN cloud application via mobile radio. At the AERZEN cloud application, data storage and processing takes place. And you, as a user, has access to the data via the web-based AERZEN digital platform application with your user account. Using a standard web browser, you can access the digital platform regardless of your computer hardware. Maybe a laptop, a tablet, or a smartphone. There you have access to the current machine data as current value, as live diagram, like you can see in the displayed screenshot. In addition, you can select a time period from the stored data, which will then be displayed in a diagram. Alternatively, you can also print out a data report, for example, for the ISO 50001 audit. But that is not all. The next step is to find out more details about the energy consumption of the individual machine, which operating costs result from this, and how efficiently the machine works. This information is displayed clearly as shown in the screenshot from the user interface of the digital platform. At the beginning, I said you can further reduce energy consumption with progress energy management. But until now, I have only talked about measurements and visualizations. Where is the possibility to save energy now? Progress energy management is not only data storage and visualization, but also data analytics. In the background, in progress energy management runs a powerful data analysis with intelligent and modern algorithm. This analyzes the parameter, air filter, intake temperature, intake pressure, differential pressure, load distribution, and compositive effects. The result is the detection of increased intake air temperature, decreased room ventilation, intake filter clogging, and intake damper leakage. These incidents are often overlooked and result in increased energy consumption. Progress energy management detects these avoidable energy consumptions and reports them early and clearly in the digital platform. This screenshot shows you such the report is displayed. With this detailed information, you can react directly and solve the incident, with the result of reduction higher energy consumption. To show you how much saving potential there is in these often unknown and ignored incidents, I've made the shown calculation from practical experience. You can see the saving potential and what of this are avoidable. I'm talking here about events in the environment of the machine that have negative influence on the machine. For example, the room in which the machine is located is not well ventilated and that the room air temperature is not kept constant. This can happen due to constructional changes or carelessness. Since this does not affect the operation of the machine functionality, the standard warnings of the machine do not alarm this. Thus, they are not directly noticed by the standard machine notification. An additional point is the clogging of the air filter, which triggers without progress energy management an alarm only at a high clogging. Prior to this, however, even medium clogging causes increased energy consumption, which can be avoided by changing the filter earlier enough. With energy management from progress, these events can be detected at an early stage, and so solving actions can be taken. Experiences of customers who already use progress energy management shows that saving of several thousand euros per year in energy costs are realistic. On the other hand, energy consumptions always has something to do with CO2 emissions. Even if you have a cheap electricity price, the issue of CO2 emissions is become more and more important for everyone. With the shown methods, you can implement the further reduction of CO2 emissions too. An additional and not insignificant aspect in this gain is transparency. Direct on-site visits to the machine are reduced, thus freeing up time for other works. Digital services and intelligent data analytics offers additional added value. They offer additional opportunities to reduce operating costs and increasing the service life of the machine. Identifying excess consumption and balance it against the optimum has never been easier. So, it is time to take advantages of these and benefit from the advantages. I hope I could give you a feeling what can our progress with the digital service energy management can do for you. We are happy to support you in the implementation. Please do not hesitate to contact us if you have any questions. Thank you very much and see you soon. Ladies and gentlemen, and now we have finished the webinar part with the presentation, and now we are coming to the Q&A. First of all, we would like to start with the questions of the topic from my colleague Markus Leidinger. We received during the webinar a lot of questions. We have not the complete time to answer all the questions. I pick out a few of the questions, and the questions that are not directly answered today, we are answering after the webinar via email. And yeah, Markus, are you ready for the first question?
Yes, we can start directly, Arndt.
Okay, yeah, so the first interesting question is, at what water depths does it make sense to switch to fine bubble aeration system?
Yeah, Arndt, this is a difficult question. My 20 years of experience tell me we have different things to consider. First, the water depth plays an important role. I would say from a water depth up to 3 meters, it makes sense to switch to a fine bubble aeration system. Why? With a surface aeration system, we will have in a deeper zone a poor oxygen demand. The deeper the basin, the more efficient is the fine bubble aeration system. The second point is the size of the plant also plays an important role. Smaller wastewater treatment plant with less than 3,000 population equivalent are mostly equipped with a surface aeration system. Between 3,000 up to 5,000 population equivalent, there is a gray zone. Both solutions have the right to exist. If we're talking about bigger plants, in the most cases, you will find solution with fine bubble aeration systems. This is my experience. And the third point, worldwide, my experience is that we can find in some region very, very old wastewater treatment plants, sometimes older than 40 years. Here you can see very often and the phase aeration system is installed because it was state of the art in this time. In summary, I can say if the water depth deeper than 3 meters, then we have a tendency to fine bubble aeration systems.
Okay, yeah, thank you. That's a very interesting and deep information about this question. And the next question is, can a frequency converter be fitted directly to your AERZEN machines?
Here I have to say, yes, we can. Our turbo blower is equipped every time with frequency converter. Blower and hybrids have this as option. Here we are flexible to the customer requirements. Both things are possible for us.
Okay, yeah, that's a good answer. When there is so many flexibilities, then we have a lot of chances to adapt different things together. Very fine. Another interesting question is, why do you use different types of machines? Isn't it better to place always the same type of machine?
Really a good question. Very often I get this question here. The decision depends on the requirement of the treatment process. Here we have to clarify where is the focus of the customer. If we're talking, for example, about energy efficiency, then very often turbo machines, delta hybrid machines, or in combination of both machines can deliver best energy performance. And another focus can be broad flow range combined with a cost-effective price. Then our solution with blowers can be interesting. Or maybe we have small machine room. Then the small footprint play a big role. And here I have to say our turbo blowers are unbeatable. What I can say, we are all prepared to our requirements. With our configuration program, we are able to deliver for all your wishes a good solution.
Hey, that sounds good. Thank you very much, Markus. So I think depending on the time slot for the Q&A, we change then the Q&A to my topic. And yeah. Markus, would you please?
I will look to some interesting question asked. First question, what I have here, can only AERZEN machines be analyzed with the analysis or also others?
Yeah, that's an interesting question too. Yeah, it's a current focus at AERZEN. Progress, we are focused on AERZEN blowers and compressors. All algorithm and analytics, they are focused on our machines. And so currently progress is only available for AERZEN machines. Maybe in the future we go further and have then the possibilities to adapt third-party components and machines, but currently these digital services are only available at AERZEN machines.
Thank you so much, Anne, for this information. And here I have a really interesting question, because I also very often I received these questions from the customer side. Can this also be retrofitted to old machines?
Yes, of course. Retrofit is this very big interest in the progress solution, and it's not only used for new machine. We made a tailor-made retrofit solution for existing machines, for blowers and compressors, turbos, for all this kind of machines. There are a tailor-made solution is available. And the point is, before we start with the retrofit and the offering the retrofit in the application, we have to check what kind of machines and what is the technical situation on the machine side. And so our technicians, our local subsidiaries, can take a look on site at the machine and the technical equipment there, and then we decide which retrofit kits fitted best for the solution, and then it's depending on what kind of digital services you want to adapt to the machine. And so we have there a few interesting retrofit kits that makes it very easy to adapt existing machines with digital services.
And I'm a little bit perplexed or surprised. This is the better word. We have now more than 20 another questions, and I'm thinking we cannot answer these questions immediately, and therefore I suggest I will choose one question, and all other questions, ladies and gentlemen, we will send you back with an email. Let me look, and I'm thinking this question can also be interesting. Is data transmission only possible via cellular connection?
No, not only with cellular connection. A cellular connection is our standard possibility, but when you have some special IT policies or some points that on the place where the machine is working, is the cellular connection not so good possible, then we have the possibility to use standard Ethernet connection. Our IoT gateway has additional Ethernet interface, and you can then connect the IoT gateway
directly with a wired IT network from your company to the internet. And there are some relevant settings possible and needed in the network router. And for these, we have then the specifications and information for your IT administrator. And if you don't want to use a cellular in communication for the data, then contact us. And during the developing process and the implementation process, then we discuss how it works, and the IT administrator gets then all information to make the safe and secure connection to our cloud application.
Thank you so much, Arndt.
Yeah,
yes,
you're welcome.
ladies and gentlemen, now we are in the end of the presentation from the AERZEN side. I hope it was very interesting for you, and I promise you all other questions we will answer in a separate email. Thank you so much for your attention. Hope we see us anytime later. Bye bye.
Yeah, thank you from my side too. See you.